Thank you, Susan. Thank you for that. And thank you to Carl for inviting me. It's been 12 years since I've been here before, last at a Carl meeting, so it's kind of fun to be here. Thank you for that. And thank you for Masood for giving my talk. Or at least the talk I would have liked to have given. How's that? I think what we've got, though, is a nice kind of segue from a number of different topics, which we're going to delve into a little more deeply, and maybe, hopefully, as well, get into some discussion about these topics. Because I think really what I think Masood and I both want to do is kind of galvanize a discussion, a dialogue, and then some action. And that's what I want to try and talk about today, is the implications. We'll continue on with that, and we'll try and work towards an action agenda of some sort. So why do we care about machine learning at all? I think the first thing is we really need to remind ourselves that it's very powerful, it's ubiquitous, it is literally almost everywhere these days. It can be opaque, so there are concerns about it but not understanding what it's doing. It is often invisible. We don't know it's there. We don't know it's having that kind of effect. But mostly we're concerned about it because it's consequential. It has a material impact in our lives. And that material impact gets expressed in lots of different ways. One of my favorite observations came from Chris Berg a number of years ago, 6 years ago now, as I mean it, when she asked the question, what happens to libraries and librarians when machines can read all the books? Well, guess what? Machines can read all the books. And her challenge to us 6 years ago was, we've got to start thinking about algorithms differently. We've got to think, and her suggestion is we think about them as patrons. And that's certainly one perspective, but we need to think about this technology as a partner, a colleague, an enabler. And 6 years ago, I think Chris really nailed it, and I think we're living in that second part now. How will we use this technology to our advantage? So here's the agenda. I'm going to start with a bit of background, covering sort of some of the ground that Masood covered, but maybe from a different perspective. And I want to try and provoke you a little bit around some issues and concepts. And then we're going to turn it over to you, because really the most important part of this morning is your issues, your concerns, your strategies, and how we're going to turn this into some sort of action agenda and move that forward. So we'll see how that goes. You will notice that it said agenda number 1. That's because there's an agenda number 2. This is Mike's secret agenda, which I'm about to reveal to you. This is the part that I really hope will come through today and future days. And that is, we really need to take a strong, value-based, research-informed leadership role in this technology. This, as you've heard this morning, is an inflection point. This is a time where we really need to grasp the opportunity that's here. And we can do it based on the value systems that we've been using and that guide our work. A value system, I will suggest, is not necessarily inherent in the machine learning community right now. So we can bring a lot to the table. But we need to do this not just for the development of machine learning, but to really advance what we do and the missions that we have. So I'm hoping at the end of today we've maybe taken that to heart. So let's start with the elephant in the room, ChatGPT. We've all used it. We've all used it, not told people we've used it. All our students use it. Everybody uses it. There's a fascinating survey that came out just this morning from the US, which indicated that something like 70% of American workers who were surveyed would happily allow ChatGPT to do their job if it meant they could go to a 4-day week. They would take a pay cut if ChatGPT would do their job for them. So there's this really interesting dynamic now about how this technology is merging with norms, I guess, within our culture. So ChatGPT, what is it? Well, first of all, it's amazing. It's pretty cool stuff. It's very disturbing if you've used it in any kind of weird way. Strange things happen. It's definitely a proof of concept. This is a technology which is showing that things like this can work. It's also seriously flawed. There are some fundamental problems in the way that it's structured, given what it's expected to do. It is just a tool, after all. It's just a service. But it's also much, much more than that tool. And we need to understand that difference. I think it's an opportunity for us to think about how we will use this technology in one form or another. It's also one of many types of machine learning. I think one of the things we tend to do is we tend to think of ChatGPT as machine learning. It is one slice of machine learning. There are lots of other algorithms and systems that do similar and different things, that work differently and similarly. ChatGPT is just this one piece. It's not the answer, it's a part of the answer. And as a result, I think it's a call to action. I think it put, as Masoud said, it was accessible, it was public, and that really created a discussion, an awareness that allowed us to probe this much more deeply and maybe more urgently. So I think it really is giving us a marching order, if you want to put it that way. Machine learning is often characterized as very complex. It's difficult to understand. People don't want to get involved in it because it's too deep and too bizarre in some cases. I'm going to give you a very simple model of every machine learning system there is, so that this model can be used to understand any of those systems in a sort of abstracted way. And it's important because this will allow you, in a sense, to critically appraise some of these systems without actually having to know the internal technical dynamics of the system. Because really they work on very similar principles. And when you see the principles, you'll be interested to see how they actually dovetail, if you will, or align with what libraries do already. So, first of all, there's some sort of problem. There's some sort of problem that this model, you're always creating a model of some sort of model is being created to respond to a particular problem. And within that problem, there's a context. And this is kind of important because they're not designed to do everything. They're not Swiss Army knives. They're very much focused on a particular problem and a particular use case or a particular context case. If you find that that isn't the case, that it's trying to be everything to all people, it's not going to be a very successful model. Something is going to be deficient there for sure. The other piece then is the first major piece is the representation area. Representation is not only the data that is used to train the system, and training data is enormous, but how that data is represented in the system. So how is it modified? How is it massaged? How does it represent itself inside that algorithm? A lot of stuff is vectorized, long strings of numbers, but how that vector works and how that vector is created is actually kind of important. So information description is huge in any machine learning system. It's rumored to be 80% of any model development is building the training data and understanding the training data and getting into a form that the algorithm could finally use it. So representation is enormous. Then the other two pieces actually are just a cycle. Evaluation, optimization, evaluation, and optimization. Evaluation is what is your objective for this model? What do you want it to do? What's it supposed to accomplish? Is it supposed to work at 80% accuracy, 100% accuracy, 50% accuracy? Is it supposed to engage in a natural conversation, as in ChatGPT? What do you want it to do? And that evaluation then tries to bring the model closer and closer to your objective. And that's what optimization is doing. Testing, retesting, finding a new way through the data, finding something that gets closer and closer to that objective. Now, neither evaluation nor optimization are value-free. If you're engineering background, you know that you can't optimize for everything. So you make choices about how you're going to optimize and what you're going to optimize for. And in some cases that might be veracity, in some cases it might be profit, in some cases it might be adaptation or popularity, but the decision on what to optimize is a critical decision for any system. And then in the same way that your goal, what you're going to evaluate, is also a key factor in what you're really attempting to do. So that model, I guarantee you can use that model to understand any machine learning system. And more than that, you can see how libraries do very similar things in terms of how we gather information, how we describe it, how we manage it, how we evaluate its use, how we optimize our services around that use. So we're actually comfortable with this sort of process, and these sort of processes. They actually align pretty well. Now that you know how any machine learning system works, You now know why ChatGPT is so bad at what it does, particularly around biographies. Why are they so awful? Why do they do very strange things when you ask it for a biography of either yourself or somebody else? It constantly gets strange things happening. You know now it's because of this. It's because of how it represents the data. So ChatGPT understands patterns and predictions. That's what any machine learning system actually does. So it really understands the structure of biographies because it has ingested hundreds of thousands of them. It knows exactly what happens. People are born, they go to school, they get a job, they have relationships, they retire, they die. Those are pretty common, in fact, almost universal. So it's really good at knowing that there's going to be this structure to the biography that you ask for. The problem, of course, is that everybody's biography is completely unique. It doesn't like unique things. It likes, go back here. The details of the problem, because it knows about patterns, it doesn't know about specifics. So the hallucinations that people describe ChatGPT having are in fact a feature, not a bug. It works that way because that's how it's assembled the data, that's how it understands things, and if it's good at patterns, it's not so good at unique things. And obviously lots of biographies are in fact unique. So there's a really interesting observation about machine learning, which people tend to get a little concerned about, called the bitter lesson. Rich Sutton, who is from just nearby, is actually one of the co-developers of reinforcement learning, which is a major theme of machine learning. But he identified this issue a number of years ago, that if there's a big lesson from 70 years of the work we've been doing in AI and machine learning, it's that general methods that leverage computation are ultimately more effective and by a large margin. So what he's saying is what really works in machine learning is lots of computation, lots of computational horsepower, and very simple, kind of almost generic algorithms that are sort of usable in lots of different contexts. You put those into a big bucket, you let it roll around for a long period of time, and it comes out with amazing things. That's how machine learning can play chess, by learning chess over and over again. It's how it defeated diplomacy, by learning by that sort of a process. The bitter lesson is this. The bitter lesson is that building in how we think about things, how we understand and use things, doesn't work in the long run. In other words, the more we try to introduce our own way of thinking, we're bumping up against the way the machine inherently wants to work and how it will solve a problem. There's a somewhat apocryphal story about the early days of machine learning, natural language processing, when we were trying to understand exactly how could we translate languages and how we could do that sort of process. And the companies that were doing that hired lots of linguists to help with them, because they would understand language, they'd understand how maybe we would transfer English to French and French to other languages. So linguists were thought to be pretty important. And the story is that one of the heads of the CEOs of one of these companies said that their natural language processing system got better every time they fired a linguist. Because the linguist was bringing their idea of language, not what the system would discover on its own. So I think one of the things that we might want to think about in this context is we have a store of understanding about how we should manage information, what metadata should look like, how people should interact with systems, and maybe not. Maybe we've got to design those systems that allow the machine learning environment to work in that kind of different mode, allow it to explore on its own and come up with possible solutions. We may have to let go a little bit, I guess, is the way to think about this, in ways that maybe we're not always as comfortable with. Just to characterize, you think about when we first started with digital resources and the internet and that sort of period of time. And we thought about that as a pretty major shift in how we were doing things. But really it was a shift in tools. We were still focused on the two things I think we still are focused on a little bit, which is we're focused on control and search. Controlling information and then using search to find that information. And that's worked well, and it's an important aspect of things. I think what we're moving to when we move to the widespread use of machine learning systems is we have to think about the focus being on learning. How can we enable a machine to learn? How can learning be the motivator for what we put out in front of people, what we develop, what we allow to have happen? It's not so much control anymore. It's about this focus specifically on the idea of learning, and learning as a North Star. So, bitter lesson. Lots of people don't like this. Probably what happens. So I want to carry on from what we heard a little bit this morning about sort of where we are with this technology and what I think we can do and should be doing as institutions, as research libraries. I'm going to do a little SWOT analysis here so that we can look at strengths, weaknesses, and opportunities and threats. I'm going to do it for myself, so this is my analysis, but hopefully it'll open up some doors and some issues that you might want to pursue going forward. So what are the strengths? Well, clearly, information access is a strength of this technology. It's really good at problem solving, at coming up with ideas that we can use. And certainly there are huge productivity gains. And we can see that within ChatGPT, but we can also see it in other machine learning modalities. And this is very strong. I mean, this is changing jobs, people's attitudes towards the work they do, and improving it vastly. There are some problems, though. And the weaknesses are around things like veracity. It kind of lies sometimes. Whether we can trust it or not, whether it is in fact trustworthy. And I think an issue around accountability. Is it accountable for what it's doing? And if so, how is that accountability expressed? Mostly these systems are not accountable in any way that we can think about. Then there's the threat side. And we're seeing that again, a lot. Threats around manipulation, deception, malfeasance. We're seeing it in all sorts of different contexts. And this, of course, is very serious. This is areas where if we don't address this in some way, it's going to very seriously undermine the value of this technology. But there's also the opportunity side. And the opportunity side for me is around partnerships. How can we partner with this technology for things like research and discovery? How can we enable this to augment what we can do in ways that we couldn't before? This is an assistant in the way we can accomplish something that we couldn't otherwise accomplish. So the opportunity side, I guess, is to look at that opportunity, that possibility, and how can we specifically leverage it? And we'll come back and talk a little bit about that. So let's walk through some of this and see how it plays out. And I think about it in terms of remedies as well as contributions. So what are the things that we need to do to counterbalance this or to enable it? And what are potentially our contributions to those issues? So in terms of information access, problem solving, productivity, two things I think would make a huge difference. One is better training data. We sit on an enormous amount of quality training data we've acquired through scholarly resources, through scholarly vehicles, through scholarly communication. It's vetted, it's peer reviewed for the most part. In many cases, we have total access rights to mine that data, or we've got open access data we can easily get that available to have. So I think training data and our data is an enormous opportunity to advance not just what we want to do, but maybe what others want to do as well. When you realize that ChatGPT was trained on Reddit, you know why it doesn't work as well as maybe it should. Reddit not being exactly the gold standard for authenticity and veracity. We've got a very different situation, and I think we need to be able to take advantage of that. So how do we convert what we're doing already into training data to make these systems much, much better? The other thing we can do, which is we talked about earlier, is around algorithmic literacy, not just for our users, but for ourselves. And really thinking about algorithmic literacy in the context of information literacy, the two really meld together. And we're seeing organizations doing more and more of this work. We need to really advance this, not just for the library, but for the campus as a whole. It's an unmet need at this point. So what about the whole issue of veracity, trust, and accountability? Two things. come to mind here that we could accomplish and do. One is the field that I spent a lot of time on in the last 6 years, which is called explainable AI. How can we get to the point where machine learning systems can actually explain what it is they've done, why it came up with a particular conclusion, what it's basing its arguments on? In other words, make it transparent in some way, accountable in some way, and trustworthy. Now, the argument has always been, well, these systems are extremely complex and opaque. We can't possibly know what's going on inside them. It's very mysterious. It's kind of magic. Data goes in, answers come out, and we don't know what goes on in the middle. In one sense, this is true. They are a very complex system with billions of parameters that are at play. But the fact of the matter is we know a lot about what goes into a machine learning system. We know a lot about what affects its processes and decisions. What's different is that often the companies that devise these systems are unwilling to build that into their systems because it impacts performance. They believe it, at least they believe it impacts performance. So they'd rather not explain. They'd rather just let it come up with an answer. I don't think that's going to be good enough for us when machine learning systems are used increasingly in more risky inventor areas, or in fact, when it's used even in consumer environments where a machine learning decision really does have a material effect on your life in some ways. So one of the things I would really like to see libraries do is really two things. One, really push for explainability in any machine learning system they acquire. So that needs to be a feature of what we're looking for in a service or a system. And you could start with ChatGPT if you want, but there's lots of others. But the other one is to think about that as an advocacy issue for legislation. Like, how can we build in something like the right to explanation into the legislation that's coming down around AI in Canada and literally around the world? It is not happening right now, or it's happening in very selective areas. But I think it is one that not only would benefit us from the work that we do, but it would benefit the larger community. And we have an understanding of how important explainability is. Should you wish to get lots of sleep and you want to get bored stiff, you can read my thesis. It's online. It'll happily drift you off to sleep, I'm sure. The other thing here, though, is something a little closer to home, and that's peer review. Peer review is broken. Peer review is really struggling. We can't do it effectively anymore. People won't participate. It's not good when some people do participate, and yet it's essential for our environment, for the ecology of scholarly communication. So peer review may be an area where machine learning can actually help, because machine learning can investigate writing, it can investigate ideas, it can investigate the corpus, and really assist people in getting better analysis of the work that's being done and how it might interact with other work and where the flaws might be, where the weaknesses might be. I'm not suggesting that AI could take over completely peer review, but it could certainly be a very valuable tool for us to use to be able to make peer review more effective. And if we don't, I think the difficulty will be even more pronounced around concerns about veracity. So the hard one, deception, manipulation, malfeasance. And this is where I think maybe the first thing we've noticed with ChatGPT was in the teaching and learning space, where we had students having ChatGPT write essays for them or contributions for them. And sometimes we didn't know that was happening, and we weren't sure how we were going to respond to that. And that's kind of important. I think there are other solutions to that one, but it's still an important issue. I worry more about misinformation, weaponization of this technology, and truly criminal activity. And it strikes me there are two things that can happen there that would be useful. One is we really do have to push for effective AI legislation, machine learning legislation. The examples around the world are kind of interesting. As you heard this morning, the Americans are looking at it very much kind of a laissez-faire view. The Europeans are looking at it in a much more controlled way. But both of them are really only looking at high-risk environments. They're not looking at the larger spectrum of what's happening around machine learning. In Canada, we have an AI Act, which is probably going to be promulgated sometime next year. And it's very weak. It's very thin. In fact, if you look at the Act, it's about 3 pages long. And all it says is the rest will be filled in through regulation later on. And we have no idea what those regulations are going to look like. This is not a real robust response to the challenges we have in front of us. So again, maybe one of the things that we need to do as libraries, as research libraries, is again on the advocacy end. We really need to make these issues, make politicians and others aware that these are concerns and move that into that regulatory space, have those discussions. We've had great track record in the way we manage, for example, copyright, even though it's still going on. We've had major successes along the way, and that's important. So we have mechanisms to do this kind of advocacy work. This may be one where we need to tackle this one in a very new frame of mind. The last thing is norms, and this does kind of relate back to the teaching and learning space. As someone who spent a lot of time in the last few years teaching, a lot of our teaching methodologies are pretty old school, and they're certainly not ready for ChatGPT, as we found out where people went ballistic when this was used by students. And so when you think about how we evaluate learning, you think about how we ask students to perform in various areas, it really isn't going to survive in an environment where machine learning is virtually everywhere. So the great news, I think, there is the norms around what we think about as teaching and what we think particularly about evaluation is going to change, and it should change. This is an opportunity to really reinvent the evaluative processes we use in higher education. Again, I think we can be someone who can contribute to that. Okay, so the most interesting one, the opportunity side. The opportunity side, as I said before, is really about partnerships with AI, using this technology to augment what we do and to advance it. And I think there may be kind of two possibilities here that are important. One is we need to get our hands on this stuff. We need to play with it. We need to experiment with it. It's way past exploring. We're no longer exploring anymore. We're using. And we need to use it in controlled environments and experiments that we can determine whether it works here or not. The technology is out there. Masood mentioned Hugging Face this morning. Hugging Face is a site of open source algorithms to let you do this work. It's along with GitHub is really the source for a lot of this code and technology. It's available to us if we would use it. So pick anything, pick any sort of area and create a skunk work around building something, trying it out, seeing where you can do with it, seeing how it could apply, where are the weaknesses, where are the strengths. It is as important to use this the way we explored how to use the internet, how we used digital objects in that sense. I think the other piece is we can do that experiment with partners. We don't have to do this by ourselves. And I'll put my plug-in, as I said to Masood, you can also invite, Central IT to help because, I'm a former CIO, so I had to put a plug-in for Central IT. They're good people, they really are. Whatever you might think. But the partnerships go beyond that. They are partnerships with other sectors, with other organizations, with other resource providers, and I think we want to open that tent to that and actually present our situation as a really interesting problem to solve, a case to solve. We have a lot of opportunity and we have a real focus in a certain area, and we have a mandate on campus which is very broadly based. So I think we could encourage people to join and partner with them. I've talked a lot about governance. I've talked a lot about regulation. And I wanted to bring this survey up because it'll help you maybe focus a little bit on this. This is from a study that KPMG did with the University of Queensland, I think a year or two ago now. And it asked, who do you have confidence in to really effectively govern AI, to do that in the best interests of the public? And I know it's going to be hard to read, but I'll just point out two. The green one is you. It's universities. The yellow one is government. So the highest area of confidence was in universities to really help govern this technology. The lowest level of confidence was government. Obviously, what's really interesting about this is the highest level of confidence is in an organization that indeed has lots of ideas and expertise and research background, but also absolutely no power to, in fact, regulations. Zero, in fact. They have influence, maybe that's it. The bottom of the bucket are the people that have all the power, but apparently aren't seen as having enough knowledge in doing it. I do this because I think this survey tells us, not just as libraries obviously, but as institutions, how important our role is in this advocacy space. It is seen by the public as the one institution that can actually do this in an equitable, fair way, in a way that looks after the interests of the public. Everybody else, and in the middle there are corporations and industry groups and designers and all those sorts of people. All those people have vested interests which are going to warp that. So it's a challenge to us, a challenge which I hope we will adopt. I talked before about the shift from control and search to learning. There's another kind of shift which I think is kind of important. Information behavior is something, human information behavior is something we're all involved in. It's how people need, seek, give, use, manage information in different contexts. So I have argued that information behavior, human information behavior, is really at the heart of almost everything we do in a library and in fact in a university. We're always trying to find a way to either maximize human information behavior or in fact shift human information behavior in a certain way that would be more productive. But we're always working in that sort of paradigm of how people use information and share it and manage it. I think we're up against now something very different, which is machine information behavior. We shouldn't be thinking about machine learning being like human intelligence. It's not human intelligence, it's machine intelligence. It's machine's way of thinking about things. So let's leverage that. Let's leverage its inherent capabilities rather than expecting it to do something it likely will not be able to do or will do very differently. So that means understanding what the information behavior of machines is. And it's why I showed you that very simple model of a machine learning system, because really what was described there was the information behavior of a machine learning system. If we can delve into that more, then these systems are not only less mysterious, but we can very easily identify what their strengths are, what their weaknesses are, what we should use them for, what we shouldn't use them for. We know why it does something and why it doesn't do something else, because its behaviors are built in to the way it's been organized, designed, and how it works. So just like we spend a lot of time in our research environments looking at human information behavior, I think we got to shift that balance a little bit and start looking at how machine information behavior works, what it means to have information behavior in a machine. So I want to present an opportunity for you. We are really blessed in Canada to have huge amounts of resources available to us. And here's a list of them. We have research organizations like libraries and universities. We have a lot of really quality scholarly training data available to us, either data that we've acquired through licensing or through open access methodologies. We have expertise in this field. Canada is blessed with some of the leading researchers in machine learning, and we have these national institutes like the Vector Institute or AMI in Alberta, or MILA in Quebec. Incredible organizations that have some of the highest talent, high quality talent people in the country working on a lot of very serious and interesting problems. That expertise is world class. We have lots of compute power. We have these high performance computing centers around the country which have learned how to capture some of the compute cycles that we need for this kind of work. We have wonderful partner agencies working on behalf, like CRKN, Compute Canada, lots of others, who are working with us in a variety of different areas. And there's funding out there, and especially there's funding for machine learning right now through groups like CFI, CFAR, which is the group responsible for the machine learning strategy in Canada, and even the various research councils. We also have wonderful high-speed national networks connecting all those people together. So tremendous resource in lots of different areas, in lots of different fields, all uniquely missioned around certain areas, all with great track records. So here's the idea. Can we create a pan-Canadian machine learning research knowledge network? Can we marshal those resources in a partnership that allows us to explore this technology, drawing from all these communities over common goals, and really advance this kind of technology within our sector? And when I say that, I probably mean higher education, but beyond that even. Can we put these pieces together effectively? And I think we've done sort of this before, and I think we've seen this sort of model before. I think the payoff will be not just for libraries, obviously, but for all the groups that rely on what we do to advance their knowledge. It could be an incubator for discovery. It can be an incubator for exploring different areas. Think about some of the really serious problems that are there, that we have resources that might open up new avenues, new directions in some sort. So I think this is an area where if we want a vision for where to take this, the good news is the tools, the participants are kind of there and have things to bring to the table. We just need to galvanize them around a vision that would bring these together as partners and make this happen. So there, in the 1980s, during the early days of AI, one of the definitions of AI was something that hasn't been done yet. As soon as it gets done, it's no longer AI, it's just the way things happen, right? It's just the way we do things. So, as an example, spam filtering, remember you used to get like a gazillion spams? You don't probably get quite a gazillion anymore, you get half a gazillion, I don't know. And that's because AI completely has dominated the spam filtering market. It's all done by artificial intelligence, and really pretty effectively. So we don't think about that as AI anymore, that's just spam filtering. So the same thing is kind of happening in this space. As soon as we figure out how to do really good cancer screening, it's not AI anymore, it's just medicine. The leading edge of this AI field is always the hype end of it. So artificial general intelligence is the one that comes up. The ability for a machine to behave like a human in almost every capacity. One of the great things about humans is we're not just machines, and we're not just ideas, and we're also physical entities that move around in an environment. So we learn in lots of very different ways than machines will ever probably learn, even robots will learn. So the whole issue of artificial intelligence, to me, is one of those hype issues, because really the issue is how good is machine learning getting, and how can we align that with what we want? And it's the alignment thing that's fairly weak right now. We just let exploration go on, which is a good thing, but it never gets aligned with values that are important and that we think are important. One of the questions that people often ask is, if someone tells you an AI is going to do something, you should ask two things. What is it actually doing, and how does it do it? And so if we'd asked that ChatGPT that question, it would say, well, I trained it on Reddit. And you'd go, okay, fine, I'm going to move on to some other system now. Or I'm going to take it with a huge grain of salt. So those questions can really help us get through some of the hype, I think. So I guess I want to know from you folks is, because it's your action agenda, not mine. I'm going to sit in my wheelchair and complain about government. What are you going to do? Are you going to grasp this as a challenge? And if so, as you've said here, how will you galvanize that not just on your own institutions, but how will you collectively address this, and maybe internationally address this? How could we work together in a much broader way? We all have lots of hugely talented people in our institutions and in our orbit. And we can bring that expertise, enthusiasm, and desire to make a difference, I think, to this particular significant opportunity. It's maybe a challenge, but it's an enormous opportunity as well. So I'm going to watch what you're doing, and I'm going to complain on Twitter when you don't do it. So, or whatever the other thing is that we're all using. Anyway, thank you very much. I know I'm keeping you from lunch.